In this video, we're going to talk about solving absolute value equations. So the question is something like this. How can we solve an equation like this one? The absolute value of 2x minus 7 equals 13. How do we find a value or values for x that will make this equation true? Well, notice that if the absolute value of 2x minus 7 is going to equal 13, then the 2x minus 7 has to either be 13 or negative 13, right? The only way to take the absolute value of something and get 13 is if that something is 13 or minus 13. So really you would end up solving two equations. 2x minus 7 equals 13 and 2x minus 7 equals negative 13. Okay, so that's the fact that I put down here. Notice that if a is a positive number and x is, capital X is what's called an algebraic expression. So our capital X is kind of like 2x minus 7 up here, and the a would be like the 13. To say that the absolute value of x is equal to a is the same thing as saying that x is either equal to a or x is equal to negative a. Okay, if the absolute value of something equals a, then that something without the absolute value had to either be a or negative a. So let's use this principle to solve some equations. Okay, solve the absolute value of x minus 7 equals 5. Well, notice x minus 7 would have to either equal 5 or x minus 7 would have to equal negative 5. Okay, and if we add 7 to both sides in this equation, we get x equals 12. And if we add 7 to both sides here, we get x is equal to 2. Negative 5 plus 7 is 2. So notice if you plug in 12 here, you get 12 minus 7 is 5, and the absolute value of 5 is 5, so that really is a solution. And then 2 is also a solution because if you plug in 2, you get 2 minus 7, that's negative 5. The absolute value of negative 5 is 5. By the way, notice our answers didn't end up being like 12 and negative 12 or 2 and negative 2. Our answers were 2 and 12. Okay, let's do another one. This time we have an absolute value equation, but the absolute value is not isolated on one side, and that's one thing that we want to do. We want to get the absolute value all by itself. So what we're going to do is subtract 10 from both sides, and we get the absolute value of 3x plus 2 is equal to 17. Okay, so what that tells us is that 3x plus 2 has to either equal 17 or 3x plus 2 is equal to negative 17. Okay, so let's solve these separately. The first one, if we subtract 2 from both sides, we get 3x equals 15. So x is 5, right? 15 over 3. The other one, if we subtract 2 from both sides, we get 3x equals negative 19. And now if we divide both sides by 3, we get x equals negative 19 thirds. Okay, now that doesn't simplify to be a nice whole number or anything, but 5 and negative 19 thirds, if you plug those in there, you'll see that you get a true statement there in part B. Okay, now the last one is kind of an interesting one, but it's something interesting will happen. Notice if we isolate the absolute value here, we get the absolute value of 5x minus 9 equals negative 10. Right, because 3 minus 13 is negative 10. But notice we can't have the absolute value of something being negative, so here there's no solution. Now why couldn't I put 5x minus 9 equals 10 or 5x minus 9 equals negative 10? Well, remember our original statement up here said that a had to be a positive number. Okay, if a is a positive number and x is an algebraic expression, then to say the absolute value of x equals a is equivalent to saying that x is a or negative a, but a couldn't be negative. Okay, so in this case what we'd say is that there's no solution. Okay, there's no value of x that we can plug in here that's going to make this true.